Okay, so let's start by rereading the problem. One number is 5 more than twice another. Okay, if their sum is decreased by 10, the result is 22. Find the two numbers. Okay, so with applications, we like to start by rereading the problem like we just did, and then asking ourselves, what are we looking for? Well, clearly we're looking for two numbers, right? Find the numbers. Now we're going to let one of the numbers be x, and I'm going to use the language they use here, right? They refer to one number, or one of the numbers, as one number, and they refer to the other number as another number. And when I look at this first sentence here, one number is 5 more than twice another, I can see that one number is referring to another number. So for that reason, if I write this down, and if I write, one number, okay, equals something, and then if I write another number using their language, equals something, because one number is 5 more than twice another, because the one number refers to another, I'm going to let another number be called x. What does this say? Well, one number, it's not 5 more than this, it's 5 more than twice another. Well, twice another would be 2x, but it's 5 more than that, and that's why it's 2x plus 5. So this is a very important step, because when you decide to call one of the unknowns x, it allows you to easily create an expression for the other, and you're basically making use of the sentence that connects the two unknowns. Okay, so for the next part of the problem, well, what do they ask? Or what do they tell us? If their sum, okay, so you take their sum and do what? Well, the sum is decreased. So we're going to take their sum and from it we're going to subtract 10. Okay, well the sum of these two numbers is going to be, well, 2x plus 5, right, plus x. That's the sum of the two numbers. But then we have to decrease that sum. That is, from it we have to subtract 10. What do you get when you do that? Well, the result is 22. So that's equal to 22. And that's the equation you've got to solve. So it's going to be, well, 3x, combining the 2x and the x, and 5 minus 10 is negative 5, equals 22. Now we're going to add 5 to both sides. So we get, let's see, it's going to be 3x equals 27. Now we're going to divide both sides by 3, and it's going to be, well, x is equal to 9. Now what does x represent? According to this, x is another number. So the other number is 9. And what is one number? Well, it's 2x, that is twice the x you just found. So 2 times 9, which is 18, plus 5, which is 23. And that's why the two numbers are 9, which is the first one, and 23. And those would be the two numbers that satisfy, those two numbers would satisfy the conditions of this problem. Okay, let's try another one now. Okay, so this problem deals with a collection of nickels, dimes, and quarters. So let's read this again together. Kelly has a collection of nickels, dimes, and quarters with a total value of $7.40. There are 4 more nickels than dimes, okay, and twice as many quarters as nickels. How many of each coin is in her collection? Okay, so I ask myself, what am I looking for? Well, I'm looking for 3 things, right? The number of nickels, the number of dimes, and the number of quarters. So we're going to start off by saying, okay, let's write that down. We're looking for the number of nickels. So once again, I'm writing down what I'm looking for. We're going to call that something. We're looking for the number, the number of dimes. And we're also looking for the number of quarters, right? So the number of quarters. Okay, so when I reread this problem, I see that well, I want to let something be x, right? And I can see that the number of nickels is in terms of the number of dimes. That is, the number of nickels refers to the number of dimes, and the number of quarters refers to as the number of nickels. So here's the plan. Quarters references the number of nickels, but the number of nickels references the number of dimes. And that's why I'm going to let x be the number of dimes. Why? Because once you call x the number of dimes, this sentence, there are 4 more nickels than dimes. Well, if they're x dimes, there must be x plus 4 nickels. And then once you have the number of nickels, there are twice as many quarters as nickels. Okay, well, this is the number of nickels, and twice that is 2 times the whole thing, right? This is twice that number of nickels. Okay, so now that you have expressions for your unknowns, now you want to create an equation that allows you to solve for the x. So, and that equation is based upon the fact that we have a total of $7.40. So if you think about how much money Kelly has in terms of nickels, well, every time she has 1 nickel, that's 5 cents, right? Well, how many nickels does she have? She has x plus 4 nickels. So you take the nickel worth, which is 5 cents, 0.05, and you multiply it by the number of nickels that she has, x plus 4. And you do the same thing with dimes. Every dime is worth 10 cents. And how many dimes does she have? Well, x. And likewise for quarters, every quarter is worth 25 cents. And how many quarters does she have? Well, she has 2 multiplied by x plus 4 quarters. And when you add up all this money together, right, the amount in terms of nickels, the amount in terms of dimes, and the amount in terms of quarters, in total she has, well, it's going to be $7.40. So this is going to be $7.40. Okay, so this is the equation I have to solve. So I'm going to start by first distributing this 0.05, and also I'm going to distribute that 2 over there. So this equation is going to become, well, 0.05x plus, and then the way we multiply decimals is you say, okay, let's temporarily forget about the decimal. And 5 times 4 is 20, and then move the decimal in 1, 2 places. So it's going to be 0.20. And then we still have plus 0.10x. Okay? And then plus, well, 0.25, that hasn't changed. But this becomes, well, it's going to be 2x plus 8. So 2x plus 8. And on the right-hand side, we still have $7.40. So $7.40. Okay, now we're going to keep everything the same, except we're going to distribute this 0.25. So now it's going to become 0.05x plus 0.20 plus 0.10x still. Okay, plus 25 times 2 is 50. Move the decimal in 1, 2 places. 0.50x plus, and let's see, 25 times 8. And one way to think about this is, remember, this is a quarter. And if you have 8 quarters, you have $2. So just plus 2 equals $7 or 7.40. Okay, let's combine like terms. So I see this term has x, that term has x, and so does this. And when I add these 2 decimals together, I get 0.60x. And then adding this one in gives me 0.65. So it's going to be 65, right? X plus 0.20. And, oh, actually, I still have that 2. So let me add the 2 to the 0.2. So that's going to be 2.20. Okay, that was 2.20. And the right-hand side is 7.40. Okay, at this stage, it's easy enough to subtract decimals, but at some stage I usually like to clear decimals. So I want this decimal to move 2 places to the right, and the same thing with this one and this one as well. So I'm going to multiply both sides by 100. That'll cause the decimal to move 2 places to the right. So 100. And let's see, 100 times 0.65x, well, that's going to be 65x plus, this is going to become, well, 100 times 2.20 is 220. And on the right-hand side, it's going to be 740. And now I'm going to subtract 220 from both sides. And I get 65x is equal to, that's going to be, let's see, 520. Okay? And now I'm going to divide both sides by 65. And what do I get? Well, let's see, 65 goes into 520. What's that going to be? It looks like 8 times. So x is going to be equal to 8. Now x represents what? Well, the number of dimes. So you have 8 dimes. And then, let's see, the number of nickels is x plus 4. Well, that would mean you have 12 nickels, right? And then, let's see, the number of quarters, well, you take x plus 4, which is what we just found, right? 12 times 2, and that's 24. So you end up with 24 quarters. And you can check your work, right? Because 24 quarters, well, we know how to calculate that, added to 12 nickels plus 8 dimes. If you add up all that money, you should get $7.40. And I'll leave you to check that on your own. Okay, let's try another one now. Okay, so in this problem, well, we're talking about a right triangle. And a right triangle, remember, is a triangle where one of the angles is 90 degrees. So it says in a right triangle, one of the acute angles is twice as large as the other acute angle. An acute angle is one where the measure of the angle is less than 90 degrees. Find the measure of the 2 acute angles. Okay, so once again, I say to myself, what am I looking for? Well, acute angle 1 and acute angle 2. So let's write, we're looking for the first acute angle. Okay, I'm going to call that something. And I'm going to call the second, well, the other thing, I'm going to call the second acute angle, the other unknown. Okay, so one of them is going to be x. So one of the acute angles, I'm referring to that as the first. And the other acute angle, well, I'm calling that the second acute angle. And notice the language, right? One of the acute angles is twice as large as the other. So I'm going to let the second acute angle be x. Well, that makes this angle twice that, right? So it would be 2x. And now what do we know about acute angles? Well, these 2 acute angles, remember, it's a right triangle. And in any triangle, the sum of the angles is 180 degrees. So one of the angles, because it's a right triangle, is 90. So these 2 acute angles have to share the remaining 90 degrees, right? Because if you take the total measure, which is 180, and subtract off the 90-degree angle, you're left with 90 degrees. And that means these 2 angles have to add to be the remaining 90 degrees. That is 2x plus x must be equal to the remaining 90 degrees. So 3x is equal to 90. Divide both sides by 3. So we've got, let's see, it's going to be x is equal to 30. And what is x again? Well, x is the second acute angle. So we have one angle that's 30 degrees, and what's the other angle, or what's the first angle? 2 times 30, and that would be 60 degrees. So these are the two acute angles we are looking for. And notice that the type of triangle we have is a 30, 60, 90 triangle, because the other angle is 90 degrees in a right triangle. Okay, let's try another one here, now that we're having so much fun. Okay, so this is a problem involving somebody working at 2 jobs. So Maggie has a job working in an office for $10 an hour, and another job driving a tractor for $12 an hour. One week she works in the office twice as long as she drives the tractor. Her total income for that week is $416. How many hours did she spend at each job? Okay, so we start with what we're looking for, right? What am I looking for? Well, how many hours did she spend at each job? So we're going to denote one of the unknowns as the office hours, right? How many hours did Maggie spend in the office? And the other one will be the tractor hours. How many hours did Maggie spend driving the tractor? And once again, we want to let one of these be x. How are they related? Well, this sentence right here, 1 week she works in the office twice as long as she drives the tractor. That means if I let x be the number of hours she drives the tractor, she works in the office twice that number of hours. Okay? And now there must be information that's unused, right, to create our equation. Well, there is. She gets paid $10 an hour in the office and $12 an hour driving the tractor. Let's see. Every time she works, 1 hour in the office, she gets paid $10, but she works a total of 2 times x hours in the office. So I have to multiply her hourly rate, which is 10, by the number of office hours, which is 2x. And to that I'm going to add up, or I'm going to add to that, how much she makes driving the tractor. Well, for 1 hour on the tractor, she makes $12. So her hourly rate at on the tractor is 12. And how many hours does she work? X hours driving the tractor. And if you add those two amounts together, that is how much she earns in the office to how much she earns driving the tractor. She makes for that week a total of $416. Okay? Let's solve this equation. So we have 20x plus 12x is equal to 416. So we're looking at 32x is equal to 416. If I divide now both sides by 32, what do I get? Well, x is going to be equal to, let's see, it's going to be 13. 32 goes into 416 13 times. Let me just double check that. Yeah. Okay, so what does x represent? The number of tractor hours, right? So she drives the tractor for this week. She drives the tractor for 13 hours. And then in the office, how long does she work? Well, in the office she spends, 2 times x, but x was 13. So 2 times 13 is 26. So she spends 26 hours in the office. Okay? So if that week she works 13 hours on the tractor and 26 hours in the office, she'll make a total of $416. So this would be your answer. Okay, hope that helped.